we're used to large language models. They're trained on everything. They consume a huge amount of information, everything they can, sort of be trained on that exists almost. And, that forms the basis of this model that you can interact with and ask questions. So large language models, they excel at sort of complex reasoning over these vast data sets. So if you look at, something like legal or even medical or pharmaceutical, where there are peer-reviewed journals, there are white papers, clinical trials, reports, you name it, it can go through all of that and does an amazing job of being able to compare data, understand your intent, and actually fetch pieces of data you need. So way more powerful than sort of the human brain is able to do and comprehend really so much more. But you still send your data over to them, their responses stream back, and there are latency issues. They need to be hosted and they need to have specific hardware. So there are limitations in that. Even with GPT-4o, we've seen much better latency speeds, but it still needs to go out. You need an internet connection, that sort of thing. Yep. Microsoft recently announced the Phi 3, or is it Phi 3 or FOFUM? I don't know. But family of open language or open small language models, SLMs. These are really the sort of most capable and cost-effective models for their size. They have incredibly low latency. And what sort of struck me is almost this evolution that we're seeing now where, like we did in web development, you had a large sort of application, that was compiled from a big data source. And, then we started going into client-side frameworks with components and, everything was sort of these bite-sized of applications, which had all those performance improvements and a number of other advantages. And it's kind of doing the same thing. So what we would look at is we've got these smaller models that are effective at doing specific things. And you would actually have a whole portfolio of different models. This is kind of coming back to what you were talking about is, are we going to plateau? And maybe the answer is yes, we'll plateau with large models, but it's about capitalizing on these sort of smaller models and having a portfolio of different sort of disciplines. One thing to sort of unpack on these is, well, before I go into that, the other point that was interesting is these small language models can often outperform the large language models on specific areas like language or coding and math. So you've got these giants that are incredibly good at a lot of different things, but they haven't been scaled down. So that was an exciting point that I thought, that you actually get better performance. But one thing that's also, and this sort of goes into the discussion, is the parameters on each model. So to understand the sort of model sizes, we look at the parameters. So you can imagine an analogy we could use is kind of baking chocolate chip cookies. So imagine you have a recipe book for making cookies. So each recipe has a list of ingredients. So you got things like your flour, your sugar, your chocolate, and you've got specific amounts of each ingredient. So in this analogy, we would say, all right, our parameters are like the amounts of each ingredient in the recipes. So is it a cup of flour? Is it 2 cups of flour, half a cup of sugar, that sort of thing. The model is like the entire recipe book. So it's got all different recipes in it, or you can think of rules for making different kinds of cookies. And those are kind of your responses or outputs. So when you're baking, or you could say we're training the model, as an analogy of baking, you can adjust the amounts of those ingredients, or really the parameters, to get the best tasting cookies. So really the most accurate responses. So the better you adjust these amounts, the better the cookies or the output will turn out. So it's an interesting way of understanding it. So in kind of more complex recipes, larger models like GPT-4, you might have many more ingredients and need to be more precise with the amounts, just like larger models have more parameters to fine tune. So that's sort of an overview of what the parameters do. So now you see where Phi 3 Mini comes in. It comes in with 3.8 billion parameters. So it sounds like a lot, but you're looking at a model that's about 14 gigs in size. So pretty manageable. With most storage on a lot of devices, that's something you could fit in. Now you look at GPT-3, which is supposedly 175 billion parameters. So you've made the jump there from 3.8 billion with the Phi 3 Mini to GPT-3, an old model, 175 billion. So you're looking at a 650 gig model. So then we go to the GPT-4. That's rumored. I say rumored because I think it was Sam Altman that was like, no, it's BS that it's 1 trillion parameters. But a lot of things online are saying it's around about 1 trillion parameters, which is 3.6 terabytes. That's massive. So that's not, now we're purely looking at storage of the model. We haven't looked at any of the processing or anything like that. So GPT-4o is still to be confirmed, but you've got massive size differences there.